All right, so as I mentioned in class, we're going to be doing two problems right now that I want to do for you before class tomorrow, just as a quick initial review. So this first problem, I have you evaluating the integral from 0 to 4 of the square root of 4 minus x squared dx. And this looks like it's kind of tricky. The key here is to recognize that if we say y is equal to the square root of 4 minus x squared, and then square both sides, we end up getting y squared equals 4 minus x squared, which looks, maybe you can tell by now what this is, but in case you can't, we're going to add x squared to both sides. And we get x squared plus y squared equals 4. And you should know that this is a circle centered on 0, 0. And in addition to that, the radius is equal to 2. All right, so let's think about this. This is basically what we're finding is this area that I'm highlighting right here. Everything above the, oh, I'm sorry, not there. Right there. Everything from 0 to 2 on this circle. So basically, we're finding the area of a quarter circle. So the area of this circle, pi r squared, is equal to pi times 2 squared, or 4 pi. But we only care about a quarter of the circle. So a quarter of the circle is 4 pi divided by 4, which gives us an area of pi, which is our answer to that integral. All right, so for this problem, it says that the velocity of a particle is given by v of t, and it tells you, suppose that v of t is an even function in miles per hour, and the area under the velocity curve between 0 and 3 is 17. And then it asks, what is the total distance traveled for -3 to 3? And you're going to write and evaluate an integral. So the key here is that we have an even function. So from -3 to 3, this is just the integral of velocity. All right, and we know that from 0 to 3, it's 17. So being an even function, remember with even functions, we just have to multiply that area by 2. So it's 2 times the integral of 0 to 3 v of t dt, or 2 times 17, which gives us 34. And because velocity is in miles per hour, the integral of that is position. That'll be in miles. All right, now for our last problem, part B says, if the particle started at a position of 2 miles when t equals -3, what is its ending position? This one's pretty straightforward. So we start at 2 miles at -3, and we know that we went 34 miles from -3 to 3. So this is simply to find s of 3. We started at 2, and we're adding that integral that we found in the previous problem up here. So it's 2 plus 34. Our ending position is at the 36th mile. And that's it. Thanks for watching, and I'll see you all tomorrow.